Welcome to all of you in the lecture of analog electronic circuits. My name is Mayank Kumar Rai. Today I am going to take a lecture on load line analysis. In this lecture, I will be covering these key points. Number one, load line. Number two, three different points. And last one, three different reasons in the context of bipolar junction transistor biasing. And the main goal of today's lecture is to learn how to draw load line and how to identify these three reasons along with three different points in a given output characteristics of bipolar junction transistor based circuit which is biased in common emitter configuration. Now I'm going to explain my first topic, which is load line. Actually, load line is a graphical method which is used to obtain the appropriate value of operating point. And this load line can easily be drawn by determining the output characteristics when no signal is given to the input. Actually, this diagram shows the output characteristics. Basically, output characteristics is a curve between collector current and collector to emitter voltage at different base current. And in this output characteristics of bipolar junction transistor, which is biased in common emitter configuration, green line shows the DC load line or state line. It has two endpoints, point A and point B. For better understanding of a load line, here we considered a common emitter configuration based circuit which consists of a single NPN transistor, and in common emitter configuration, as you know, that bipolar junction transistor is biased in such a way that the base to emitter junction is forward biased and collector to base junction gets reverse biased. And in this circuit, input DC voltage, which is VBE, is applied between base and emitter, and total DC output voltage, which is VCE, is taken between collector and ground. Actually, this is the voltage between collector to emitter, and emitter is connected to ground. That's why here total output voltage is equal to VCE. And here power supply means VCC is needed to bias the BJT as well as to supply the power required for the operation of this circuit. And once we apply the DC voltage to bipolar junction transistor, then the current and voltage will be established in the circuit. And the arrows of various currents indicate the direction of current flows under normal operating condition, which is also called active mode, where emitter to base junction is forward bias while collector to base junction is reverse bias. And this is something we already know, that the bipolar transistor uses as an amplifier in active mode. Therefore, to explain load line concept in detail, we have considered here a common emitter configuration based circuit which is operated under operating mode. And after setting DC operating condition in this given circuit, we apply a KVL to the collector side to find the value of collector to emitter voltage. And when we apply a KVL to the collector to the collector side, we get an expression which is formulated as VCC. This is the power supply which is equal to drop across collector to emitter VCE plus drop across collector resistance IC into RC. And this equation shows that the both VCC and RC are the constant value, and it is the first degree equation which is represented by the straight line on the output characteristics. And this straight line is called DC load line. And this DC load line has two endpoints, and these two endpoints will be calculated under two steps. In first step, where VC is maximum when collector current is 0, then from the equation 1, when we substitute the value of IC which is equal to 0, then we get VCE, which is VC max, which is equal to VCC. And in step 2, where IC becomes maximum when collector to emitter voltage is equal to 0, then from the equation 1, when we substitute the value of VCE which is equal to 0 in equation number 1, then we get IC max which is equal to VCC divided by RC. Then after determining these two values, means VC and IC, we just draw x-axis and y-axis. After that we mark point A, which is equal to VC max whenever the value of IC is equal to 0 and its value is VCC. And then we mark B, which is IC max, and it is equal to VCC divided by RC whenever the value of VC is equal to 0. And finally, by adding the points A and B, the DC load line is drawn here, and the slope of this load line is equal to -1 by RC, and RC is the collector resistance. Now in next slide I am going to explain three important points that include saturation point, active point, and cutoff point. And in addition to these points, I will also explain three different reasons with the help of output characteristics of bipolar junction transistor, which is connected under common emitter configuration. So to explain these points and reasons, here I have considered a common emitter configuration based circuit, and with the help of its output characteristics, I am going to explain three different reasons and three different points. So let's get started. First point, which is point B, which is called cutoff point, and this is the point where the load line, means red line, intersects the IB equals to 0 curve, and this is the point where base to emitter junction no longer remains forward biased, and normal transistor action is lost at that point. That means at that point bipolar junction transistor is turned off. Now next is saturation point, point A. This is the point where load line intersects the IB equals to IB saturation curve, and the corresponding point on x-axis is defined by VCE sat. That means saturation voltage of collector to emitter, and the region between VCE equals to 0 and VCE saturation is defined as saturation region. And the region between point A and B, point A is saturation point and point B is cutoff point. So the region between saturation point and cutoff point is called active region. And this is the normal operating region for the bipolar transistor, where bipolar junction transistor acts as an amplifier. And in this region, when a load line intersects the zero signal base current, or a given base current which has been calculated under DC operating condition, is called operating point or Q point, and it is also called quiescent point. And the corresponding voltage on x-axis is defined by VCQ or VCE, which is equal to VCC by 2. And the corresponding value of collector current on y-axis is defined by ICQ or IC, which is equal to ICM. This is the maximum value of collector current divided by 2. And this maximum value of collector current is equal to VCC by RC whenever the VC is equal to 0. So, in a given output characteristics of a bipolar junction transistor, which is biased in common emitter configuration, has 3 different points and 3 different regions. First point is cutoff point. This is the intersection between load line and IB equals to IV0 curve. Second point is saturation point. This is the intersection between load line and IB equals to IB saturation curve. And third point is operating point or Q point in active region. This is the intersection between load line and zero signal base current. And first region, which is called cutoff region, it is a region below cutoff point. And the region between VC equals to 0 and VC equals to VC saturation in extreme left hand side is called saturation region. And the region between cutoff and saturation point is called normal operating region or active region, where bipolar junction transistor acts as an amplifier. So now I am going to stop here. Thank you so much.